What if the universe as we know it isn't exactly as it appears? Imagine for a moment that the reality we experience daily, every sunrise and sunset, every conversation and every memory, is part of an incredibly sophisticated simulation. This isn't just a plot for science fiction films, it's a serious scientific hypothesis known as the simulation hypothesis. Today, we will deeply explore how this intriguing idea aligns with the mysterious world of quantum mechanics, offering compelling evidence that reality might be encoded in ways we are only beginning to understand. The simulation hypothesis suggests that our reality is essentially a computer-generated construct, much like an ultra-advanced version of today's virtual reality games. Initially proposed by philosopher Nick Bostrom in his groundbreaking paper, "Are You Living in a Computer Simulation?" The theory argues that future civilizations with advanced computational powers could simulate detailed realities indistinguishable from their own. Physicists and philosophers alike have found the simulation hypothesis compelling because it offers explanations for some of reality's most puzzling aspects. Elon Musk famously stated, "There's only a 1 in billions chance we're not living in a simulation," emphasizing the plausibility of this theory given the trajectory of technological progress. Quantum mechanics, the physics of the very small, describes particles like electrons and photons in ways classical physics cannot. Central to quantum theory are two extraordinary phenomena, superposition and entanglement. Superposition suggests that particles exist in multiple states simultaneously until measured. This means an electron could theoretically spin in two opposite directions at once until we observe it. Entanglement refers to the phenomenon where two particles become linked and actions performed on one particle instantly affect the other, even if they're light years apart. These quantum mysteries challenge traditional views of reality, suggesting a more profound underlying structure, one that might align with computational frameworks of the simulation hypothesis. Why would quantum mechanics hint at a simulated universe? Let's consider the principles of quantum mechanics as computational shortcuts. Firstly, quantum uncertainty and superposition resemble computational strategies to conserve processing resources. A simulated reality wouldn't need to determine the exact state of every particle until it is observed, similar to how video games render graphics only when necessary. Secondly, quantum entanglement mirrors data linking in computer programs. Just as a simulation might instantly update interconnected data points, entangled particles instantly reflect changes, defying classical limits of speed and distance. Finally, the discrete, quantized nature of quantum phenomena resembles digital encoding, indicating reality may indeed operate similarly to binary code in computational systems. Physicists and philosophers provide compelling insights that further strengthen the connection between quantum physics and simulation theory. Physicist Tom Campbell suggests our universe functions as a virtual reality, with consciousness acting as the player navigating through reality. According to Campbell, quantum mechanics reveals precisely the kind of behaviors one would expect from a computationally rendered universe. Philosopher David Chalmers also embraces the simulation theory, arguing that simulated worlds would be fundamentally indistinguishable from physical realities for their inhabitants, highlighting quantum mechanics as a potential indicator of simulated underpinnings. Physicist and author Brian Greene points out that quantum mechanics could naturally emerge from computational processes, offering scientific credibility to the simulation hypothesis. If the simulation hypothesis is accurate, what does this mean philosophically? Would it diminish the value of human existence, or could it actually enhance our understanding of reality? Philosophers argue that discovering we live in a simulation doesn't inherently diminish life's value. Instead, it could deepen our appreciation for the complexity and beauty of existence, prompting profound questions about the nature of consciousness, free will, and purpose. It might suggest our actions, experiences, and intentions could hold deeper meanings beyond mere biological occurrences. Recognizing our reality as potentially simulated introduces profound ethical and existential considerations. If reality is simulated, what ethical obligations might exist toward the creators of our simulation, or toward other simulated beings? How does this reshape our ideas of morality, accountability, and destiny? Would knowing we are part of a simulation encourage or discourage ethical behavior? These questions reveal deeper implications beyond just scientific curiosity, transforming our fundamental understanding of existence and responsibility. The simulation hypothesis, particularly in relation to quantum mechanics, challenges conventional perceptions of reality, suggesting our universe may be encoded, computed, and perhaps even programmed. As quantum physics continues to reveal the enigmatic nature of existence, humanity finds itself on the verge of a potentially groundbreaking shift in understanding reality itself. Far from diminishing our experience, this new perspective can enhance our awareness, enrich philosophical exploration, and inspire us to ponder deeper questions about our place in the universe. Thank you for joining us on this extraordinary journey. Don't forget to like, subscribe, and share your thoughts below as we continue unraveling the mysteries of our fascinating simulated universe.